Guys, Assalamu alaikum. This is Mohammad Giyasuddin. Today, again, I'll discuss about some equation related to nuclear physics. Dear guys, in fact, I'm delivering my lecture related to nuclear physics too long anyway. And today, I'll say about three equations which are very important and significant for doing numerical problem and for understanding the creative question and for going into the nuclear phase concept. Okay, guys, look at the whiteboard. I have written some equation which are n equal to n naught e to the power minus lambda t. Dear guys, this is n naught e to the power minus lambda t. So we have to know here what is t and what is t, what is n naught, what is n. Okay, we have to understand this. Actually, it is decay, radiative decay law, and is exponential. Okay, and for doing this mathematics, we have to have the clear concept about n equal to n naught e to the power minus lambda t. Here, t is time. T is time. Okay, and lambda is decay constant. Lambda is decay constant. Okay, and n naught. What is n naught? N naught number of atom at first n equal to n naught, and n is remaining atom. N is remaining atom. So if question gives you initial atom and decay constant and decay time, then you can do mathematics for finding out the remaining atom. Okay, and if question gives you remaining atom, or if question gives you the number of atom first, okay, and give time, then you can find out the decay constant. Okay, there guys, question taken n equal to n naught e to the power minus lambda t. Again I said n equal to n naught e to the power minus lambda t. Here t is time, lambda is decay constant, n naught is number of atom initially. Okay, n equal to n and n equal to number of atom. Okay, t to form this equation, you can draw t equal to minus 1 over lambda ln n over n naught, n over n naught. Okay, try to remember minus sign 1 over lambda. If question gives you lambda n naught, you can find out the time decay. Okay, just by the calculator you can do this ln. Okay, t equal to minus lambda here, decay constant. N is actually the remaining number of atom, and what is initial number of atom. Okay, and if question gives you an n naught lambda, you can find out and t half equal to 0.693 over lambda. Yeah, t half means actually decay half life, actually half life. Half life equal to 0.693 over lambda. If question gives you lambda, you can find out half life. Okay, and then just you can find out half life by this formula. And if question gives you lambda, you can find out mean life. This sign is mean life. Okay, the mean life equal to 1 over lambda, or you can find out t half equal to 0.693 mean life. Okay, and this sign refers to mean life. Okay, just if question asks you to find out the half life by the mean life, then you can apply this formula 0.693 mean life sign. Okay, and these equations are very important. You have to remember this. Okay, that is again I say in short, n equal to n naught e to the power minus lambda t, t equal to minus 1 over lambda ln n over n naught, and t half equal to 0.693 over lambda, and mean life equal to 1 over lambda T half equal to for 693 mean life. Okay, mean life sign. Actually, this sign is a mean life, and this sign is half life, and this is the time. Okay, distance del m equal to z and p plus n m n minus capital M and C. Okay, what do you mean by N? What do you mean by Z? And what do you mean by MP? And what do you mean by MN? And what does it mean? There guys, del M is mass defect. Okay, and Z is actually over what is number of, this is a number of Newton, N number of neutron, and Z number of proton, and this is mass of proton, and this is mass of neutron, and this is mass of nucleus minus. Okay, that means this mass defect del M equal to Z is a proton number, and MP mass of proton plus N is neutron number, and Mn is neutron mass minus nucleus mass. Okay, if question gives you the nucleus mass, neutron mass, proton mass, number of proton, number of neutron, then you can find out the mass defect. Okay, you can find out mass defect, and try to remember always mass of nucleus would be deducted, would be minus. Okay, actually this formula same here, just we have written here minus mass of atom mass. Okay, minus atomic mass, all are same. Mass defect, that means if question gives you nucleus mass, then you can apply this formula. If question gives you the mass of atom, then you apply this equation for deducting the mass defect. Okay, there guys, and this formula actually same, and here B means binding energy, B means binding energy, this is binding energy. Okay, and same, this same formula we have put actually this is binding energy means mass defect multiplies C square. This is binding energy. Okay, this is binding energy. Okay, binding energy equal to mass defect, and see here light velocity, the velocity of light. Okay, dear guys, just if you know the atomic mass, nuclear mass, proton mass, number of proton, number of neutron, then you can find out the binding energy. Moreover, you can find out the mass defect, and if you can find out the mass defect, you can find out the binding energy. And for that calculation, you have to remember the velocity of light. Okay, and this formula binding or energy over mass. Okay, but this mass number equal to del m c square over mass number over a here mass number. Okay, and you can find out b over a by putting the value a mass defect and light velocity. Okay, mass defect and light velocity, v over a equal to del m c square over a. A means mass, atomic mass. Okay, see here velocity of light, del m is a mass defect, and this mass defect we find out by this formula. Okay, and usually we use this formula equation where we have put the mass of atom. Actually, mass of atom and mass of nucleus same. Anyway, okay, finally I say del m formula ZMP plus Mn minus M nucleus, or you can say del M equal to ZMP plus Mn minus M atom. They is here binding energy equal to ZMP plus Mn minus M atom, bracket C square, V over A equal to del M C square over D over A equal to del M C square over A. Here D over A mean binding energy. Okay, that's all today.